Okay, to show that 3 points are collinear, right? The end position must be the longer guy, AC, must be K times of AB. The end result might not be a K, but you must make it to become a constant. Okay? The starting position says that A, B, and C have the vectors A, B, and C respectively. So first, I know that AB is B minus A, right? Not? And this is a proof that you must have as a skill, okay? As a skill. Next is AC. I think one of you wrote something like this. So it's C minus A, right? Not? Right? Okay? But you look at here, they gave you C for free. All I need to do is to put this into here. So C is lambda A plus 1 minus lambda B minus A. This part can see? Okay? Group all the A's together. Don't group the lambda together. I think you make the lambda the subject, right? Right? You try. Yeah, not bad. This part can understand? Factorize out the A. Oh, this is lambda minus 1 plus 1 minus lambda B. This part can understand? Okay? But I want it to be AB. So I know that this is going to be equals to negative A of 1 minus lambda. Can you see? Because I want to switch it to negative A plus B 1 minus lambda. So nice. Can you see both got 1 minus lambda? Take out the 1 minus lambda. What are you going to left with? B minus A, right? B minus A, right? Yeah, what is B minus A? AB law. So which means that AC is equals to 1 minus lambda times of AB. Oh, so the explanation. Only Ryan wrote the correct explanation. Since AC is equals to K times of AB and they have a common point A, AC is A, B, and C are collinear. Okay? So this is how you prove the collinear. And this is actually a very easy proof already.
Is the last part of the explanation right?
No.
So it means if you reach AC equals 1 minus lambda AB, then that's too much.
Enough, yes. It's good enough. Okay? Now the next one. Not really, because they are not collinear yet. You know what I mean? Not? Your job is to show that they are collinear. Okay? The diagram shows a circle with a diameter this. R lies on the circumference of a circle. You will realize that actually this part doesn't use anything of this part. This is a part 2. There's a part 1. I erase it away because I feel that it might be too hard. Okay? But when it comes to this part, right, the cross one, right, I want you to write down 2 things. Number 1, look here. If A cross B equals to 0, it means 2 things. Number 1, either A equals to a 0 vector or B equals to a 0 vector. That means one of them must be a 0 vector. Or A is parallel to B. Why? Because the angle that they make together is equals to 180 degrees. Okay? And A cross B is magnitude A, magnitude B, sine theta. When you have sine 180, right, it becomes equals to 0. So which means that A is equals to K times of B. These are 2 things that you must know. I think among your probably only Joshua, last week you did say out when I asked, right? You probably remember this. A cross B equals to 0 means either one of them must be a 0 vector, but they will tell you that both of them are not a 0 vector, then A parallel to B. This kind of question came out in the EJC 20181 that I gave you. Okay, so it is given this. Now, many of you, the starting position is wrong. The starting position is not use this and go and make something. Okay, is to make use of this, is to be introduced. That means this is a free fact that I'm going to give you that you are going to use later. Okay, so they already asked the starting position is by considering this. Usually they will tell you the starting position, or by considering this, by considering cross product, by considering dot product. Then we got to first says that SR cross QR is equals to R minus S, because that's SR, right? Cross R minus Q. Point S is somewhere that it doesn't matter. Okay? And I think the only person that tried to expand this and expand this correctly is Matt. You did expand, Did you expand? Ryan? So first, and then because it's cross, right? The order is important. R cross R minus next one. S cross R. You cannot write it as R cross S, okay? Because direction is important, yeah. Next one. Minus R cross Q plus S cross Q. Okay? This you must know. R cross R, N. Can tell me or not? Zero vector, very good. A vector cross itself is zero because the angle that they make is 0 degree. This guy is zero vector. This part can understand? Okay? The crucial part is this. You want to make use of this part. Can you see? This is where it comes in. Can you see Q cross R is equals to here? Okay? So I'm going to write this down as positive of Q cross R. You see when I switch the position, negative R cross Q is the positive of Q cross R because there's a negative there. Okay? Plus S cross Q minus S cross R. Okay? So this guy is the free guy that they gave you. Oh, Q minus R cross S. This is the given one that they gave you. Given. Okay? Can? Plus S cross Q minus R. Can see not? Factorize, I factorize. The S is in front, I factorize out the S is in front. Okay, this is the part where students make mistake. This one and this one. Are they the same? Yeah, yeah. Many students say this is 2 of Q minus R cross S, which is wrong because this is Q minus R cross S minus, when you change the order, this will be Q minus R cross S. What is this equals to? 0 or 0 vector? 0 vector. SR cross QR is a 0 vector. This means that SR is parallel to QR. Therefore, SR is equals to K times of QR shown.
So if 1 minus what?
Say again?
Q minus R plus S minus Q minus R. Oh.
Yeah, they're the same thing, right? They're the same thing. They are the same thing, right? Q minus R cross S minus Q minus R cross S. Same thing, right? Yeah. Yeah. Yeah, that's why I wrote there. Cross, not times. It's cross.